In this example, we're going to walk you through all of the options that we have available when creating profile toolpaths. We'll be demonstrating all of the features in both the standard and advanced form to help you understand the various options and their benefits. So let's just go to File, Close, and then we're going to go and create a new file. Working with a single-sided job size, the width is going to be 12, height is also 12. Material thickness we're working with is 1/2 inch. We're going to set the Z0 position on the material surface, and the XY datum position is going to be set to the lower left-hand corner. Then we could go ahead and press OK. So we're going to start by drawing a simple rectangle just to demonstrate the profile toolpath. So over to Create Vectors in the Drawing tab, we're going to use the Draw Rectangle icon here. And here I'm just going to specify a width of 6 inches, a height of 6. We'll go ahead and press Create, and you can see it's been added to the centre of our job there. So let's just close that down. So now we've got our vector, let's switch over to the Toolpaths tab on the right hand side. First thing we need to do is set up our material, just check over the settings that we've got here. So 1/2 inch thick material, XY is in the lower left hand corner, Z0 material surface, then check over the rapid Z gaps above the material, ensuring that the clearance and plunge are safe and appropriate for what it is that you're doing. Home and start position, X0, Y0, and then the Z gap above the material. That seems safe enough, so I could go ahead and press OK here. So the profile toolpath will allow us to cut to and from a specified depth, and will follow along the outside, the inside, or on a selected, open or closed vector. So this toolpath is perfect for cutting out objects, but it can also be used for engraving text onto the material surface. So with our vector selected, we're going to go and locate the profile toolpath under Toolpath Operations, first icon, and this is the profile toolpath. And when I click on that, that will open up the 2D profile toolpath form. And so within this form, we have various options to control the profile toolpath. Notice we have this option here to show advanced toolpath options, and if I check that, we have a longer list of variables, and that just gives us more detailed options to enable us to have more control over the profile toolpath. Now for the first part of this tutorial, we're actually going to switch off the advanced toolpath options, and we're just going to look at the standard options that we have within the form here. So let's start at the top at the cutting depths. So the start depth, for this case, we're going to have that at 0. You'll never need to alter this if you're cutting from the material surface. But if we're cutting into a pocket where material's already been machined away, then you'll need to specify the start depth to how far into the material you want the toolpath to start from. So in this case, we're just going to leave that at 0.0. And so the next option in the list is the cut depth, and this is where we specify how far down we want to cut into the material. Now in this case I want to cut the square out of my material block, so I need to cut the entire thickness of my material, which we know is 1/2 inch as we just set up the material earlier. So what we could do in here is we could enter that value of 1/2 inch. Another tip here is if you didn't remember the value that you set your material thickness to, you could simply enter Z and equals, and the software will input the value that you entered for that material thickness in the form for you there using the calculation Z equals. Okay, moving on down is where we select the tool that we want to use to cut this square out. So if we use the select option here, that's going to open up our tool database. So this is where we have our default tools. We can add in new tools, copy tools, we can delete tools, we can edit the settings for the tools themselves, and in this case I'd like to use a 1/4 inch end mill, so we're going to use the 1/4 inch end mill from the end mill section here, and I could just glance over the settings, ensuring they're safe and appropriate for the material that I'm using. So I could go ahead and press OK there. And then you'll also notice we have an edit option in the tool selection area here, and if we use the edit option, this allows me to edit the settings for this particular toolpath, so we don't overwrite the default settings that are in the actual tool information in the tool database. And so if we created any further profile toolpaths in this same session, it will remember any edited information that we gave this specific tool. So it's always good practice just to go into the edit option to check over the tool information, just to ensure that the settings are safe for the particular toolpath. In this case, I'm happy with that, so we'll go ahead and press OK. Then we move on to machine vectors. And we have three options. We can machine on the outside or the right, inside, left, or on the vectors. And this diagram effectively shows where the tool will go. So the outside is where the tool is going to go on the outside of the vector. Inside is going to travel on the inside of that vector. And on means that the center of the tool will be on that vector. In this case, we're going to use the outside option. As we're creating a simple cutout, we want to maintain the actual dimensions of this square, so we'll use the outside option there. Then we have two direction options, so we have climb and conventional, and this is down to the way the cutting teeth on the tool engage with the material and the way that the chips are removed and deposited. There is plenty of discussion on which is best to use, as one may give a better finish than the other, and the best advice that I can give you is to run test cuts on your material first. If you find that the finish looks better on the waste material on the part that you're cutting out, simply switch the direction to the other option. In this case, we're just going to go with the climb option. And then we could come down to the bottom and use this option to calculate this toolpath. And so this will automatically open up the 3D view where we're actually displayed this toolpath. So if I just move my material over so we can take a look at what's happening here. So this red line here, okay, so this is our start position. The tool's going to travel over here to our first point where it's going to plunge down, represented by that green line, and then it's going to run across and it's going to cut out the first pass, and it's going to go deeper, and then it will go round, cut the second pass, and again as it gets back to the start point it's going to go down again and create the third pass, and then down for the final pass where it will cut the part out. And so we can see that it's cutting this in 4 separate passes. So how do we control the pass steps that we set for the tool? So if we just go back into the profile toolpath form, we can edit the pass depth using the tool section here. We could use the select option if we wanted to make a permanent change to the tool that we've got saved in our tool database, or you could just simply edit the value here. If you wanted this to remain the same, you could just simply press OK and would look at using the edit option, where we're just going to look at editing the pass depth for this particular toolpath, and it won't affect the settings for this tool within the tool database. So here we could just look at increasing that pass depth to 1/4 of an inch, and then we could just simply go ahead, press OK, and then calculate that, and we can see now it's going to cut that part in 2 passes. And so each pass being at 1/4 inch gives us a total thickness of 1/2 inch, which is our material thickness there. And so if we went ahead and preview that toolpath, you can see it's cut the entire thickness of our material there. I could double click on the waste material to delete that, and I can see my finished cutout part. Let's just reset that preview, and we're just going to go back into the profile toolpath, and if we just use the select option here, go back into our 1/4 inch end mill, you'll see the pass depth hasn't changed because we use the edit option to edit the pass depth for the tool for this particular toolpath, and it hasn't affected the settings within the tool database. So let's just go ahead and press OK there. And so the next option we have in the form is to add ramp plunge moves. And so what this will do is, rather than plunge the tool directly down the Z-axis into the tool's pass depth, which can be quite strenuous on the tool, the ramping option will allow the tool to ramp into the material, which means that it will cut to the specified pass depth in a zigzag motion at a distance specified within the form that we input here. And so it adds a horizontal element to the movement, and this means that it will just improve the wear and tear of the tool and can enable for faster plunge rates. So in this case, we're just going to check the option to apply ramp plunge moves. I'm going to specify a distance in here of 3 inches, so we have quite a long ramp into the tool's pass depth. And then we could simply press calculate to recalculate this. And you can see our toolpath there. If we just take a look at this of the x-axis, and you might be able to see this a little better here. And so you can see that the ramp is represented by this aqua line that we have here. And so the tool's going to ramp in 3 inches, and then it's going to go back on itself until it reaches the 1/4 inch pass depth, in which case it will then go around to cut the square. And once it meets that start point, it's going to ramp back in 3 inches, go back on itself until it reaches the full 1/4 inch pass depth there, in which case it will then go around and cut the part out. Now 3 inches is quite long for what we're cutting, so let's edit the ramp distance and we'll make that 1 inch. So to do that, let's just double click on the profile toolpath. It's going to open up that toolpath there. Just going to change the distance, we'll make that 1 inch. Then we could go ahead and press calculate, and so you can see it's updated here, and we can see that we're now ramping in at a steeper angle and just ease into the pass depth where we'll cut the part out, and again ramping in to then cut the part out. So let's just put that down the Z view, and then we'll just go ahead and preview that toolpath. Now if we didn't have a vacuum hold down system in place on our machine, then this square is more than likely to fly out of place on the last pass because there's nothing to hold it still. So if we didn't have a vacuum hold down, we could look at using the option to add tabs to the profile toolpath. Now tabs are small strips of material that hold the part we are cutting out to the material block we are cutting into, where you'd manually remove the tabs yourself using a chisel and hammer to break the part away from the material block, and then apply some hand finishing to remove any evidence of a tab being there in the first place. So let's just go ahead and reset the preview. Just going to double click to go back into the profile toolpath. And then we're going to use this option here to add tabs to Toolpath. So when we check that option, we're now able to alter the length and the thickness of the tabs that we want to put in place. So for this example, I'm just going to keep these values as they are. So they're quite hefty tabs here. This is purely just for demonstration purposes. So once we've specified the length and the thickness, we could use the Edit Tabs option, and this will open up the tabs form. So the first option we have here is a constant number. So what we've got there is 4. I can edit the number in here, and whatever number I input within this form will be how many tabs will be placed within my part. So if you put a constant number of 4 and then use this option here to add the tabs, it will add in 4 tabs that are equally spaced around our part. And we can see them represented by the yellow square with the letter T inside. If I wanted to delete those tabs, I could use this option here to delete all tabs. Then we have the option to apply a constant distance between the tabs. So if we use that option here, you can specify a distance. For example, let's put 2 inches in there. So minimum number of tabs is 1, maximum is 10. Then we could go ahead and add those tabs, and you'll see it will evenly space these tabs out at a distance of 2 inches. Okay, if we wanted to input our own tabs, we can use the delete all tabs option, and I could just come over and you'll see my cursor has a tab symbol next to it, and that just allows me to input a tab. So when I hover my cursor over the vector, you'll see that we're displayed with a check telling me we're okay to insert a tab, and I can click using the left mouse button on my mouse and that will input that tab. So I can go around, add in further tabs, and if I wanted to move a tab I could just simply click on the tab and then just drag that around to a position that I wanted it to go in. And then again I could just click to insert a tab. If I didn't like the position of any one of these tabs, I could click on the tab and that will remove that. So let's just input a tab over here, and then we could just close that down, and then we could just simply calculate that. And so then if we just tilt the view here, we can see how this toolpath is going to look. So it's going to ramp in, go around, cut the first pass, ramp into the second pass, come over. As it gets to a tab, it's going to retract up by 1/4 of an inch, as that's the thickness we specified for that tab. It's going to come across and it's going to plunge back down to the pass depth of 1/4 of an inch and go round until it meets the next tab. So if we go ahead and preview that toolpath, we'll just put that in the Z view, you can see those tabs in position there, and that's going to hold our part in place. Now realistically, for the size of the part that we're working with here, 1/4 inch tab is probably too thick. You might want to go a little bit thinner, but just so you're also ensuring that it's safe to hold the actual square block to the material that we've got here. So that covers all of the basic options we have available in the profile toolpath form. So now we're going to look at exploring the advanced options. So let's just reset this preview and close out of the preview toolpath form. With that toolpath highlighted there, we're just going to delete that toolpath, and we'll just use the yes option here because we want to delete that. I'm going to go back over to the 2D view here. Now I'd like to add a few more shapes to our work area, so let's just switch back over to the design commands. Okay, so we're just going to take this square that we've got here, I'm just going to move that up slightly. I'm going to come over and use the draw circle option, and I'm just going to draw a circle in here, close that out. I'm going to draw a rectangle, and I'm just going to roughly sketch in a rectangle like so, close that. Then we're going to take this rectangle, put it into transform mode, and then using control in order for us to create a copy, I'm just going to drag that down so we've got our copy of our new rectangle there. Okay, so I'm okay with these vectors that we've got. Let's just switch back over to the Toolpaths tab, and then we'll just go into the Profile Toolpath form. And then we'll use this option here to show the advanced toolpath options, where ultimately we're going to walk through the form looking at all of the advanced options that we can use to control our 2D profile toolpath. Now going back to the new vectors that we created here, what I'd like to do is run a profile pass that runs along the outside of this square and on the outside of this rectangle here. And I'd also like to create a profile pass that runs on the inner vector of this rectangle here and the inner vector of this circle here. So you might assume that we'd need to create two separate toolpaths, one for the outer profiles and one for the inner profiles. And let's just select all of the vectors here just by box selecting them. When I let go, we can see that they are all highlighted here. And then we're just going to calculate this toolpath with the original settings that we've got here. So just going to go ahead and press calculate. And I'm just going to come over here just to tile our windows, just so we can see what's happening in both views here. Now if we take a look in the 3D view, you can see it's a little difficult for us to determine whether something is being cut on the outside or on the inside. But if we go over to the 2D view, we can clearly see the actual pass that the tool's going to take. We can see the arrows is pointing in the direction. So we can see for the square, it's cutting on the outside, so it's on the left hand side of this vector here, and it's going around to cut that out. Same for the rectangle at the bottom here, it's going on the outside, so we can see that toolpath going on the outside of our vector here. And if we go to the inner vectors, you can see that the toolpath is actually going on the inside of those vectors, and we can see that judging by the actual toolpath direction in the 2D view. And so you can see that the software has cut around the outside for the outermost vectors, and if the software finds vectors inside of those vectors, it will cut on the inside for the internal vectors, which is exactly what we want here. And the profile toolpath knows that if it finds any vectors inside other vectors, to machine those vectors on the inside, to cut those out while still cutting the outside of the outermost vectors. So let's just double click to go back into the profile toolpath, and we'll look at some further options within the advanced options form. So the first thing I'd like to do is go back into the edit tool option, where I'd like to bring the pass depth down to 1/8 of an inch, and then we could go ahead and press OK. You'll notice that now I've changed this, you may have noticed that the number of passes here that's displayed has changed from 2 to 4. So originally we had a pass depth of 1/4 of an inch, so it's telling us it's going to take 2 passes to cut the entire material thickness, or the cut depth that was specified here. Now I've changed the pass depth for the tool to 1/8 of an inch. The software has now updated the information here to tell us that it's going to cut that in 4 passes. And so the software tries to evenly distribute the steps as long as they do not exceed the pass depth for the tool. And so you'll see here we have the option to edit our passes, and this gives us the ability to customize the pass depth. So if we select that option there, you'll see that we're now presented with the specify pass depths form. So at the top of this form, we're told we have a total depth of cut of 1/2 an inch, which is taken from our cut depth, which we specify here. And this is essentially our material thickness, which we specified. To the left here, we are presented with a graphic that shows the position of each one of the passes relative to the actual block of material. And we can select a pass by clicking on the pass depths here, and you'll notice that when I click on a pass depth, the line is highlighted indicating where that pass depth is. Not only can I click on the pass depths here, but I can click on the actual pass depths in the graphic itself if I wanted to. I can also look at deleting pass depths if I didn't want a pass depth in there. For example, I could select the 1/4 inch, and I could use the option to delete that, and it will delete that pass depth, so we're just left with 3 passes. And then we could select a pass and we could manually change it. For example, I could take the 1/8 inch pass here, and if I come to this box here where we specify the depth, I could alter that to a number that I like. So I could put in 1/4 inch in there, I could press apply. You'll notice that it's changed in our pass depth list, and the graphic has also updated that too. Now the pass depth defaults are all being populated using this calculation here, which is using the actual pass depth of the tool. So here you can see it's displayed as 1/8 of an inch. To then create the pass depths up to the depth of cut that we specify in the form here, which is 1/2 an inch. And so we know that 1/8 of an inch fits into 1/2 inch 4 times. And that way we're not left with any small remaining pass at the bottom. Now what happens if we change our pass depth to just under 1/8 of an inch? Do we then end up with 5 passes? Well, let's take a look. So let's just cancel out of this form. We're going to go into the edit option here. We're going to change the pass depth of our 1/4 inch end mill. We're going to make that 0.124 this time, and we could go ahead and press OK. So now that we've changed that, we can still see that this is going to be cut in 4 passes. So let's go into the edit passes option here. So you'll see that the 0.124 is being picked up here, and yet it's still saying that it's going to calculate this at 4 passes at 1/8 of an inch per pass. And it's done this because this option here to maintain exact tool pass depth isn't checked. And if the software detects a minor last pass depth that could be shared out equally in minute amounts to the other previous pass depths to reduce the passes from 5 to 4, then the software will. However, if you wanted to maintain the exact tool pass depth, then you could check this option here and then use this option here to set the passes, and you'll see it's updated the passes, so we now have 5 passes, where each of these passes are at 0.124 and then the final pass is at 0.004, so a very small pass there. Now I don't need to set my pass depth to 0.124, so I'm just going to uncheck that, then use this option here to set the passes. Now another way to specify a number of passes, and another way to populate the passes the tool will take to cut through the material, is by specifying the actual number of passes in this box here, whereby I could simply just up this, say, to 8, and the software will create equal passes to the number that we actually specify here. So it's saying that we're going to get 8 passes in a 1/2 inch material, and the depth is going to be at this value for each pass. So let's just go back to 4 passes. So we're just going to use this option here to set the passes to the original 0.125, and then we could just go ahead and OK that to come out of there. Another option that we have available to us in the advanced toolpath options is the allowance offset. And this is where we can specify an allowance to overcut or undercut when we come to run our profile pass. And all we do here is we simply enter a value. Now a positive value would mean that we undercut our part, so we're leaving on more material, and a negative offset would mean that we overcut, and so we're actually cutting past the vector into the actual part itself. For example, if we put in an allowance offset of 0.25, so using the same diameter as the actual tool here, and if we just come to the bottom and press Control and calculate, you'll see that it's just updated that for us. Okay, it's a little bit difficult to see here. At the moment we are looking at the wireframe toolpath drawing. If we come over to this icon here, we're just going to toggle to the solid toolpath preview here, and you'll see that we've presented with these purple lines. Now these purple lines actually represent the area that's going to be cut away, and so you can see that we're leaving on 1/4 of an inch around the actual vectors here. So when we come to preview that, so if we just preview that toolpath, we can see that we're leaving on more material. And again, this is a good indication. So if we just switch the visibility of that toolpath on, and so seeing that solid view, it's a good indication of where the actual tool is going to go. So let's just go back in. We'll just reset that preview. I'm going to go back into the profile toolpath by double clicking on that profile. We're going to go to the allowance offset, and this time we're going to put in a negative allowance. So put in negative 0.25. Go down to the bottom and again press Control and calculate, so you can just see the preview here, and we can see that the tool is now on the inside as it's overcutting by 1/4 of an inch from where it originally was meant to. And again, we could just go ahead, calculate that, and then preview that toolpath. And so applying a negative allowance like we have here can be handy, especially when working with slot together parts. So let's just go ahead and reset that preview. I'm just going to close out of the preview toolpath form, double click to go back into the profile toolpath, and here we're just going to change the allowance offset, and we'll just reset that back to 0. Now, in order to get a very consistent and clean profile to the edge of your part, you may want to do a separate last pass, where you'll leave on a small allowance which will cut the profile toolpath at a small allowance that you actually set here. And by doing this, we're keeping the tool away from the finished part by a small distance to go round and cut the the passes, and then what we can do is remove the fine shaving, the distance or the allowance that we specified here across the full depth with a separate last pass. So you may want to use this to eliminate witness marks created from each pass depth where you've cut down in the stages. So let's use the option here to do a separate last pass. I'm going to input a very small allowance here, 0.01 for this example, move down the form and use the option to calculate that. And the 2D view, we currently have the solid toolpath drawing visible. We come up to this icon here, just going to toggle from the solid view to the wireframe view. That way I can see the actual directions here. Now if we just zoom in over here, you can see we actually have two paths here. Now this first path is going to come in and it's undercutting by the 0.01 allowance that we set, and it will just cut all but the last pass. And then it will move on to this pass here, and this is the final pass, being the only pass which actually cuts to size. And what it does, it uses more of the length of the cutting teeth to machine away the tiny amount of material that is left on for the last pass, where we reduce the amount of witness marks on our part. But you need to be aware that the tool you're going to use has cutting teeth at least equal to the full cut depth. Otherwise you may risk the tool and machine damage from forcing the tool shank into the material. And this is a really nice feature to use to create clean cuts. So if we just double click to go back in here, you'll see that we also have the option to reverse the direction of the last pass, which then goes back to the whole climb and conventional debate, which is down to the way the cutting teeth on the tool engage with the material, and the best advice I can give you is to run test cuts on your material first. So if we checked that option, come down and use Control and Calculate, you'll see that we've reversed the actual last pass there. Okay, so let's just go back into the form. We're just going to switch this off for demonstration purposes, and we'll just zoom to our limits there by using this icon here. Now within the advanced section of the profile form, you may notice that we have the extra option to add in 3D tabs to the tabs section. Now 3D tabs are quicker to machine as the tool does not retract, where 3D tabs are triangular rather than rectangular. So let's look at adding in 3D tabs. So first I need to select my vectors, so they're all selected there, and then what we could do is we can go on to add tabs to the toolpath, and we'll just leave the tabs set as they are here, except we're just going to use the option to apply 3D tabs. Again, we're going to keep that at a length of 1/2 inch, and the thickness of the tab is going to be 1/4 inch. Come down the form, then we could go ahead and press calculate, and then if we just take a look in the 3D view, you can see that we have these triangular tabs in view here. So let's just preview that toolpath. So I'll use the preview selected toolpath option. We'll just put that in the ISO view and just zoom in there, and you can see that we have these triangular tabs, and so the tool ramps up to the tab height at the top of the triangle over half the distance of the tab, and then it goes back down again, essentially creating these triangles. So let's just put that in Z, and we'll just close out of the preview toolpaths form, and we'll just double click to go back into the profile form. So let's just switch off the add tabs to toolpath option and go down the form. We're going to look at the ramp section here. Now we've seen the ramp option in the basic form where we can specify a ramp distance. Here in the ramp section we have more advanced options to apply in the ramp moves. So if we check the option here to add ramps to the toolpath, we are then presented with 3 types of ramps that we could use, where we could look at smooth, zigzag and spiral. Now if we use the smooth option here, what will happen is this will follow one consistent plunge to the distance or the angle that we specify here. So let's just go for an example with a distance of 1 inch. We're just going to come down to the bottom of the form. I'm just going to go ahead and press calculate. I'm just going to reset this preview. And so if we just zoom in over here and take a look at the actual toolpath, you can see this aqua line, which we mentioned earlier, is the ramp line. You can see it's coming in and it's travelling over the 1 inch distance that we specified until it meets that pass depth, and then it's going to go and cut the part out, and then as it approaches the second pass, it's going to ramp down again by 1 inch smoothly into the pass depth and then cut the second pass out, and it will do the same for the next 2 passes. So if we just take a look at this in the actual toolpath preview, we'll just slow this preview right down and we'll just preview that. So you can see it's ramping down and it's going to cut the pass at that pass depth, meets up with the point where it's going to ramp down again, and then complete the next pass, and then it's going to ramp on the third pass, and so on. And you can see how the ramp moves are working there until it comes in and creates the actual final pass. So let's just speed that up just to cut all the other parts out. We'll just put that in Z, and then if we just undo last there and go back into the profile toolpath, just move down the form. This time we're going to look at the zigzag, which we did actually use earlier, where we plunge gradually like the smooth option, but then it will come back in the opposite direction as well, only ever taking off half of the pass depth on each ramp going into the material. So let's just press Control and calculate there, and we can see those zigzags here. So again, just like we did at the start of this tutorial, and you'll see how those ramp moves look there. Then we have the option to apply a spiral ramp. Now the spiral ramp will begin at the top of the material, and what it will do is it will come into the material, and as it travels around it slowly plunges to the full pass depth over the distance of 1 pass until it finally reaches the bottom and fully cuts the object out. So if we use the spiral option here and press Control and calculate there, you can see that this ramp just goes across the entire part. So when we go ahead and calculate that, we could take a look at this in the preview. If you just maximise the 3D view, I'm just going to slow this right down. We can preview that so you can see it's just constantly ramping in there, and then we could just speed that up if we wanted to, and it will do that for all of the other cuts as well. Now you're probably wondering if you can still use spiral ramps when we have tabs in place. So let's just find out. So let's just close that down. We'll just go ahead and tile our windows, go back into the profile toolpath form. Okay, with everything selected, let's use the Add Tabs option, and then we come to the bottom of the form where we simply press Calculate. Just going to reset that preview, and then what we can do is we can just preview that toolpath, and you'll see that it's included the tabs here. If we just undo that and just switch the visibility of the toolpath, you can see that the actual ramp includes the tab, or it's aware of the tab that is there, and so it makes sure that it doesn't cut through the tab itself. So the spiral ramp is just another way that we can eliminate the stress placed on the tool, plunging straight in and removing the full pass depth all in one movement, where you're just taking away a minimal amount which will slowly build up to the full pass depth. Okay, so let's just put that in Z, and then we're just going to close out of this preview, undraw that toolpath, and we're just going to double click to go into the profile toolpath form. So going back into the form, you'll notice that we have the option here to apply a ramp on a lead-in, and we're going to come back to this shortly. So let's just see what the leads section is all about. So to click on the leads tab, we simply click on the word leads and that will open up that tab. And this is where we can look at how we can control the lead in and out of a job. Now this can help to eliminate witness marks that may be left from where the tool plunges into the material, and it does this by using what the software sees as waste material, which is any material outside of the cutout, and it will use this to plunge the tool into the material away from the actual finished cut. So we have two types of leads. So to add a lead, we simply use the option to add leads, whereby we can add in a straight line lead, and this is where we apply an angled lead into the pass, and then we have a circular lead whereby we can apply a radius lead into the actual cutout. So let's start by looking at the straight line lead. So here we're going to specify an angle that we want the lead to come into our pass. So here we're just going to up the angle to 45 degrees. Then we could add in a lead length, so just going to alter that. I'm just going to increase that to 1/2 inch, and then we could just simply go ahead and press calculate. Okay, so you can see that we are presented with an error message telling us that one or more leads were clipped or removed. And to avoid gouging, one or more leads had to be reduced in length or removed completely. Check the toolpath is still suitable for your requirements. Let's just go ahead and press OK there, and we can just take a look at what's going on. So you can see we've got a lead in for the bottom rectangle, we've got the lead going in for the square, we have a lead for the circle here, but we have no lead for the rectangle inside of the square here. And that's because it won't be able to create a lead into a sharp internal corner. So what we could do is we could look at altering the start point for the rectangle vector that we've got here. So let's just undraw the visibility of that toolpath. I'm just going to double click to go back in there. I'm going to go into the leads. I'm just going to bring this down. Now one way of doing this is by altering the start point of the vector by going into node edit mode, or another way, or a quicker way in this case, what we can do is jump over to the start at option, and this is where we can choose the start point for the vectors where the toolpath is going to start the toolpath. At the bottom here we have an option where we can move start points to be closest to the selected point on a vector bounding box. So I'm going to use this option here, and you can see we can specify the corners, the centre tops and centre sides. In this case we're just going to go with the centre side option here, so we move the start point to this point here, and that will apply to all of the other vectors also. So if we go back to the leads, just check over those settings, and then we could go ahead and press calculate, and you'll see now it's able to create the leads on all of those vectors there. Now we've moved the start point to the centre left hand side of this vector. And we'll talk more about start at points later on in this tutorial. So going back to the leads, if we just zoom in, we're just going to take a look and focus on this area at the bottom here. So we can see that the toolpath is going to come in and it's starting just outside of the intended cutout, and this is where the tool will plunge into the material, and then it's going to lead in and travel around the part cutting the first pass. Then it will retract out and it's going to go back and plunge in at the start of the lead position, lead in, and then travel around to create the second pass, and so on. So if we just preview this toolpath, I'm just going to slow the speed right down so you can see exactly what is happening here. And if we preview that, so you can see it's plunged in outside in the waste material, leading in, and it's going around to create the first pass. It's going to retract, and it's going to go back to the start of the lead and lead in and come round, and it will do that 4 times until we finish the actual final pass there. Now the only problem with this at the moment is that when the tool approaches the end of the first pass, it's going to retract on the edge of the final part. So we may want to add a lead out also, so that the tool doesn't finish cutting at the edge of the finished product. It will just finish out in the waste material. So let's just speed that up, and then we're just going to reset that preview. I'm going to close this down, and I'm just going to double click to go back in there. We'll just look at tiling our windows here, put that in Z. And so if we go back into the leads option, we have the option to add in a lead out, where we can specify an overcut distance. So instead of plunging in and out the material in the same position, we can overcut by a distance that we enter and then retract out in a different position. So we avoid entering and leaving in the same place in our cutout. So we're going to do a lead out here. Okay, for the overcut distance, I'm just going to put in a small distance of 1/4 of an inch. It's going to overcut that by 1/4 of an inch, and then we could simply come over and press calculate. Okay, so we've got that message that we had earlier, so we're just going to OK that. I can see clearly here what that is, and that's the internal rectangle here. So if you take a look at the actual lead out, you can see it's much shorter than the lead in, but that's okay. That's not going to cause us a problem, as we still have a lead out. It's just been clipped. So if we just put that in Z, and then what we can do then is we could just again slow that down. If we just maximize the 3D view, and we're just going to zoom in on this particular area here, where we can see the part leading in, and it's going to go round, and then it's going to overcut by 1/4 of an inch, and then it's going to lead out, and then come back, plunge back in, lead in, go around, overcut by 1/4 of an inch, then lead out, and so on. So let's just preview that. So we're just going to speed this up a little bit more. So it's leading in, doing its pass, going over, leading out, and it's going to come back and create the next pass. Okay, so we'll just speed that up for us. And then let's just go ahead and reset that preview, put that in the Z view, tile the windows, and we're going to go back into the profile toolpath form, into the lead section, and this time we're going to look at using circular leads. And this is where we specify a radius to lead into our part. So here we're going to go the radius of 1/2 an inch. The lead length in this case, we'll just make that 1/4 of an inch, and then we'll put the overcut distance to 1/4 of an inch also. So what we could do is we could go ahead and press calculate. Again, we've got this warning message, and this is more than likely due to the fact that we're trying to use a circular lead in the actual circle vector, and so it will have to be clipped or completely removed to reduce the chance of the tool entering the finished part. So we're just going to go ahead and press OK there. So let's just maximize the 3D view here, and again we'll just zoom in on this area over here, and so we can see that curve going in. And if we just go ahead and preview that toolpath, we've got a more subtle curve going into the actual cut path, which may give you a better finish overall, as using a straight lead with quite a sharp angle may cause the machine to make a sudden turn, which isn't going to give you a greater finish as what may be achieved with the circular lead. Now, as I mentioned earlier, leads can also be used in conjunction with smooth and zigzag leads. So let's just increase the speed there, and we're just going to reset that preview. We'll just close that down. We're going to go back into the form here, and then if we go into the ramp option and use the add ramps to toolpath, you'll see that this option, ramp on lead in, is enabled, and we can do that on the smooth. The only thing we can't do that on is the spiral ramp. So using the smooth ramp, we're going to check this option to ramp on lead in, and you'll notice that all of this information is now greyed out because it's taken the information from the actual circular lead options. And so then what we can do is we can just go down and we could just go ahead and calculate that. Again, It's throwing up a message. It's probably due to the circle at the top there. We'll just OK that, and then we can just take a look at how this part is going to look. So we're just going to decrease the speed of this, and we'll take a look at the leads and ramps used in conjunction with each other. So if we preview that, so you can see it's ramping down, and it's going to go around to create the first pass. And again, this is all just to alleviate the stress of the tool plunging directly into the material. Okay, so again, let's just up the speed of that, and then we'll go ahead and reset that preview. We'll close down the preview Toolpaths form. We'll tile our windows, and we'll put that in the Z view. We'll go back into the profile Toolpath form, and now we're going to look at the ordering options. So I'm just going to switch off the add tab, switch off ramps. I'm also going to switch off the leads. I'm just going to go straight into the order section. And so this allows us to have a little bit of input in the way that the software chooses the order in which it will machine them, where we can specify one or more ordering approaches to try. And we can do that just by simply checking the boxes. So if we wanted to, we could be very specific, and I could uncheck all of the options apart from the left to right example, and that will cut all the vectors from the left side and then finish off with the right hand side. You could also look at just selecting bottom to top. For example, if your CNC is set up to work from bottom to top and you have multiple parts to cut, then you could set the order to go from the bottom to the top, so you can take parts out to hand finish whilst the machine is still running the other objects in your job. We can also select multiple options here, and what the software will do, it will choose the fastest route for machining based on the items that are checked here. And if we wanted to be really specific, where we solely wanted to choose the order, we can use the vector selection order option. So if we just uncheck these and we check the vector selection order here, what it does is it creates the toolpath based on the order that we select the vectors in. So if we just click in the white space and we say that we want to cut this vector first, followed by this vector, and then this vector last, when we come to calculate that, you can see it's chosen that order. It's cutting this one first, moving on to this one second, third and fourth. Now there is an exception to the manual selection here, and that is when you have vectors inside of other vectors. For example, if I selected the square first, then selected the inner rectangle, the inner circle and then the outer rectangle, the software will always machine the inner vectors before cutting the outer vectors. It will still maintain the order that you selected, but it will always ensure that it cuts any vectors inside of other vectors before cutting the actual outer vector. So you just need to keep that in mind when using the vector selection order. If we could just go back into the profile toolpath there, go back to the order, you'll see we have the option to use a grid order, and this option will join using a grid based approach with the size of the grid based on the size of the parts. Then we have the shortest path option, and this option will try and determine the shortest possible path. So then what we can do is we can then move on and think about the start at position. So we briefly looked at that earlier when we was dealing with the lead. So we'll move on to start at positions. And this is used to closer control the movement from one vector to another and can help eliminate tool entry and witness marks in key aesthetic areas. So we have three options here. We have keep current start point. So if we select that, that's just going to use the actual start point for the vector, and this can be very useful if you need to ensure that the cutter doesn't plunge onto a critical part of the job, and these can be changed if you wanted to by changing the start point of the node in node edit mode. And so the start point may result in less efficient toolpaths, whereby it increases cutting times because it may take the machine longer to move between each shape being cut. Then we have the option to optimize the start points, and this is where the software will try to calculate the shortest path, and so it minimizes the distance between link cut moves. But the downside here is that the cutter may plunge or mark important surfaces on the machined edge. And then we move on to the start points to be closest to selected point on vector bounding box, which we looked at briefly earlier. And so this is particularly useful if you wanted to alter the start point to all of your vectors in your job to a common point without having to go into each individual vector to alter the start point separately. So you can choose from the corners, the centre top and bottom, and the centre left and right. For example, if I change that to the top right hand corner, just press Control and calculate, you'll see that the start point is on the top right hand corner of each of the bounding boxes for those vectors. Again, we could do that to the right hand side in the centre, Control and calculate, and you'll see it's moved them there also. So then we come to the final option in the advanced form, and that's the corners option. And here we are able to add sharp external corners and sharp internal corners. Now to explain the corners option, we're going to look at using a different example. We'll look at a part that has both sharp internal and external corners. So let's just close out here. We're just going to delete that toolpath, and then we're just going to delete those vectors also. Let's switch back over to the drawing tab. We're just going to maximise the 2D view, use the option here to zoom to fit. Just going to go into the draw text option. I'm just going to put in a simple letter, the letter E, using Times New Roman, press apply, close that down, take that, press F9 on the keyboard to centre that, and holding down shift and pulling on the top right transform handle, just going to increase the size of that. And so here we have a vector that has both sharp external and internal vectors or corners. So let's just go and switch back over to the Toolpaths tab. And we're going to look at creating a beveled edge around the letter with a V-bit tool on a simple profile pass. That will demonstrate how the corner feature works. So with this E vector selected, let's go over to the profile toolpath. So for the start depth, we're going to start that at 0, cut depth, we're going to cut down 1/4 inch. So just going to do 1/4 inch there. Tool, we use the select option to open up the tool database, in which case we're going to use the 90° 1/2 inch V-bit, and then we can just go ahead and press OK. So here we're going to machine on the outside, as we want the bevel to be on the outside of the letter E, and we could come down to the bottom here and just simply press calculate without any corners being applied here, just to see how the part looks. So if we go ahead and calculate that, we can see the toolpath there. We can see straight away that we've got rounded corners here, and so let's just go ahead and preview that toolpath. And so something that was so simple to create adds a really nice effect to the letter here. However, if you look closely, you can see where the tool has rolled around the internal and the external corners, providing us with these rounded areas where ideally we would like to see the sharp corners that the original letter has. So let's just go back into that toolpath. So just going to double click there, and we're going to go into the corners option. We're going to look at adding the option to apply sharp external corners. So we're just going to look at external corners to begin with, and if I check that, and then if we just go down and use the calculate option, then what we can do here is we can actually see the line of the external corners, and you can see it's took a turn to create these nice sharp corners. And so if we just go ahead and reset that preview and then preview that toolpath, there we can see we have a nice sharp corner on the actual external corners of the letter on the bevel. However, the internal corners still have no definition as it's still rolling around. So let's have a look at applying the sharp corners to the internal corners. So again, let's just go back into the profile toolpath. So let's come down to the bottom of the form, go into the corners option, and select the option to apply internal corners. Now you'll see we're displayed with an allowance for the cutout tool. Now this isn't something that we need to specify, this is something that we actually need for when we come to cut out the letter of the material block. And so this value here is the distance from the letter to the edge of our bevel. And so that when we do come to cut the part out, we know that we need to offset our toolpath by this amount. So what we're going to do here is we're just going to copy that value by highlighting it, right click and use the option here to copy that value, and we'll use that when we come to run the final profile pass to actually cut the letter out of the material block. So then we could go ahead and press calculate. And so we can see in those internal corners, the toolpath has now taken the tool's edge up into the internal corners. So if we reset that preview and then preview the toolpath there, we can see now that the corners are much better defined, where we have nice sharp internal corners. And the software's achieved this by retracting the V-bit tool up slowly into the corner to create this sharp internal corner and the sharp internal beveled edge. So all we need to do now is run the cutout pass using another profile toolpath to cut the letter out. So let's just close that down. We'll just tile our windows, and with that vector selected, I'm going to go back into the profile toolpath. So here we're going to specify a cut depth of Z equals to input the material thickness in there. I'm going to choose a tool from the tool database, so use the select option here. In this case, I want to use the smallest end mill that we can to prevent any noticeable radius edges on the internal corners. So I can see here I have a 16th inch end mill there, and that will do. So we could just go ahead and press OK to machine that on the outside. And then we need to apply the allowance offset. So remember, this is that 1/4 inch allowance in order for us to cut out the allowance from the corner section on that last toolpath. So if we just paste that value in there, and then we come down to the bottom, and we could just simply press calculate, and then we could preview that toolpath, maximize that. You can go ahead and delete the waste material, and you'll see we are left with a nice looking beveled letter ear where it has sharp external and sharp internal corners. So let's just close out of this form here, and we're just going to look at one final thing in the profile toolpath form. If we just double click on the profile toolpath there, I'm just going to go down to the bottom, and you'll see at the bottom we have the option to have the vector selection. At the moment it's set to manual, and this means that we manually go in and select our vectors for our toolpath. And if we use the selector option here, we have various options that will allow the software to automatically select vectors for us based on various parameters that we choose within this form. And there are various other tutorials that cover the vector selector in a lot more detail, and you can find a link to one of those in the related video section for this tutorial. So let's just close that down. And so that completes this guide on the profile toolpath form. Thank you for watching.